Welcome to today's webinar, Consolidate MySQL Shards into Amazon Aurora using AWS Database Migration Service. Our presenter today is John Winford. John is a Senior Technical Program Manager with AWS. Today with us, we also have Ed, Michael, Knievel, and Arun. They are our webinar moderators who will be engaging with you and answering your questions throughout the presentation. John, welcome. The floor is now yours.
Thanks very much. Glad everybody can join us today. I'm here obviously to talk about the consolidation process that you can do with MySQL Shards into Amazon Aurora. As was mentioned earlier, we're going to go through a presentation, but at the end of it, we're also going to dive into a live demo so everybody can see just how the process works. Right, so as previously mentioned, we have moderators online answering questions. Depending on how things go, we may have time at the end to answer a few more questions or review some of the more prominent questions that are applicable to everyone. But our overall agenda is, as you can see on the screen, we're going to start off with talking about some of the basics about how the AWS Cloud can help, both with MySQL sharding and other database-related problems. We're going to take a look about the problem is that we're trying to solve, obviously about MySQL. Our solution that we're going to propose is, of course, Amazon Aurora. So we're going to talk a little bit about what Amazon Aurora can do and how it can help resolve these issues. And how we're going to migrate to Aurora is going to be the database migration service. So we're going to spend a few minutes talking about that. After talking about those products, we're going to dive into the details about the solution to the challenge that we have. And saving the best for last is, of course, a live product demonstration outlining just how easy it is to do MySQL shard consolidation using DMS and Aurora. So first thing on our agenda is talking about the benefits that the Amazon Cloud can bring. When migrating your database to the cloud, you do more than just change the location. You leverage the power of the cloud. We've found in the past that customers appreciate the flexibility that platforms like EC2 offer, and many do run database engines there. But it's important to take into account some of the other things that are available when you're doing a migration, in particular, the benefits that a managed service such as RDS can bring to a cloud migration. So the cloud obviously makes things easier, cheaper, and better. Really, the areas that we're focusing on is getting rid of the ongoing database maintenance and the drudgery that is involved in running a database. We try to automate as much of this as possible and give you the ability to do things like provision a database in 6 minutes. Or if you're interested in making sure that things are redundant, you can provision what we call a multi-availability zone database with a few mouse clicks. These are the kind of things that if you wanted to set up manually before a managed service could take days to weeks to accomplish. It's also important to realize that you can get rid of some of the more mundane things like patching and updating. We can apply patches with a few clicks of a mouse, again, taking on the order of a minute. Backups are fully automated. You can get detailed metrics. And best of all, you don't have to maintain shards. The long and short of it is you're leaving time for DBAs, database engineers, to optimize and improve instead of doing routine maintenance. So how do we end up here? And by here I mean in a process where you've got a bunch of MySQL shards. If we take a few steps back, chances are things ran fine, but then growth happened. When faced with the prospect of scaling your relational workloads, there's generally been two options, scale up or scale out. Scaling up is easy. You just buy a bigger database host. Scaling out is more difficult. It requires you to shard your database into several physically independent pieces such that they can run on their own host. Obviously, this is a situation that many of you have found yourself in, which is why you're all here listening today as to how you can get away from what's turned into a bit of a maintenance nightmare or a lot of overhead. So despite the difficulty, it has been a pretty common trend for people to scale out. Availability of commodity hardware coupled with the increased need for system resources has made the effort required to shard a workload worthwhile. One drawback of this is, though, of course, is you've got to maintain all these shards. If you've got 4 shards, you basically have 4 databases to manage. And even so, in many cases, people decided to do this as it was more cost-effective than scaling up. You take into account the advent of managed services, such as Amazon's RDS, well, you get rid of some of the administrative overhead. That's not to say that it's a great solution, but, it's definitely more feasible than it was in the past. Most sharded systems follow a standard pattern, that being data is divided on some key, maybe a customer ID, something like that, and distributed across some shards via the mapping function. This mapping function is probably done in the application layer of whatever it is that's using the database, and it's basically, just the application factors in where the information gets stored and then where it gets read out. There's many variations, for example. Some systems keep reference data in a separate system or in a single shard, and some replicate the reference data to all shards. Either way, the complexity in sharding typically lies in the application layer, making the consolidation of shards a relatively easy exercise. In this diagram above, which you're going to see different variations of it as we proceed through the presentations today, the map simply refers to the application mapping traffic to each individual shard. So now I'm going to spend a few minutes on Aurora. We feel it's a great solution to the sharding problem, but it's worth understanding where it came from and what we're trying to solve. All right, so if we take a step back a couple decades really, relational databases like Oracle, SQL Server, MySQL, and even Postgres were designed as multiple layers of functionality in a monolithic stack. In such a stack, nothing scales independently. Things all fail together, they're very tightly coupled, and function at the lowest performance denominator. In fact, one of the reasons NoSQL movement has been so successful is people needed to scale their databases. However, nobody ever said they didn't want transactions. So let's see what people did when they tried to scale their relational databases. First, they tried sharding. In a sense, this scales, but you lose the ability to join data sets, and your application becomes far more complex. Second, people decided to try a two-phase commit by coupling at the SQL layer. While this was arguably simpler from a design point of view than sharding, you got really bad performance, and two-phase commit is just not something you really want to deal with. Third, people decided to throw an immense amount of science at the problem, coupling buffer caches together and storage at the same time. Basically, if you think about it, this is what Oracle RAC is. While people worked out the technology and loved the challenge of it, you could argue, it's not quite right yet. For example, most mission-critical RAC clusters are complex to use, incredibly expensive, and have a bunch of highly paid DBAs dancing around chanting config spells. Basically, none of these are a great solution. So, what do we have with? Or where do we end up? Let's break apart the bottom of that monolithic stack. Let's have a distributed storage system, one that you only write log records to and never data blocks, one that copies data so it's redundant, and one that has its own monitoring system that can repair itself when needed. Once that's spread across an entire AWS region, you've got an application server that can live anywhere. And that pretty much solves a lot of those problems we talked about on the prior slide. In the end, you get Amazon Aurora. Speed and availability of high-end commercial databases. If you look at that rack system, you really don't need it anymore. But coming with it is the simplicity and cost-effectiveness of open source. There's no big licensing fees that come along with Aurora. It's simple pay-as-you-go. And to top it all off, you get drop-in compatibility with MySQL. For those of you that were paying attention to our reInvent announcements last year, we also have a version of Amazon Aurora shortly being released that will work with Postgres if that's more your cup of tea. With Aurora, you get enterprise-class performance, you get 5 times the throughput of standard MySQL, and you get a high number of reads and writes, and not to mention a really low latency on your read replicas. What that means is things perform really well. Aurora scales up to be significantly faster than MySQL, especially the larger it grows. So if you think about that statement, this is why it works so well when you can consolidate various MySQL shards into Aurora. Your performance actually gets to be substantially faster. Hence, being able to run it all in a single instance instead of multiple shards. So don't take my word for it. Here is a graph one of our gaming customers in Japan took. Basically, they were originally running on an R3 4XL with RDS MySQL. And when they went to Aurora, you can see they had a fast increase in performance and basically much faster response for them and all of their customers. Now, cost of ownership. You're probably thinking, oh great, he's preaching on about some excellent product, but it's going to cost the world. Well, that's actually not the case. Just to reiterate why we're talking about consolidating your shards, it's not just because Aurora performs better, it's because running shards can cost a lot of money. So assuming everything's running in RDS MySQL right now, you've got your 4 shards, and basically you've got to factor in the cost of running the instance and the storage for each of those shards. In this example, 4 of them adds up to close to $14 an hour. Now, you switch to Aurora. To run this same sort of configuration, you can probably run for a lot less. Basically, Aurora requires less compute power to do the same amount of work, and right off the bat, you're down to $9.29 an hour, which is about 32% less expensive than what we had to start with. But if you think back to those graphs and charts that we had a few minutes earlier, you got to remember that Aurora is extraordinarily performance under load. What this means is not only do you have to have less nodes, but you can actually scale those back. So instead of running those super big servers before, you can go down an instance size and save even more money. So now you're at almost a 50% savings, basically costing about $6.90 an hour to run those 4 MySQL shards in a single Aurora instance. Here's an example of a customer that was using hundreds of shards for performance reasons. Now this was hundreds of shards across multiple different databases, but one particular cluster, they consolidated 29 shards into a single Aurora cluster. And obviously you can see, there's going to be huge cost savings with that. And even with that consolidation, they've still got 30%, or rather utilization is only 30%, so they've got a lot of headroom to grow there. It's also good to note that if anybody looked at Aurora earlier on, we've increased the range of instance sizes available, and we now have smaller Aurora instance sizes available for use, which brings in the possibility of using Aurora even for small workloads. Just something to be aware of. Obviously, a big, powerful database, people get interested in it, and we've had quite a number of enterprise-class customers run up workloads on Aurora. Here's a few companies you may find familiar. It's just a small selection of people using it. Chances are, if it works for them, it'll probably work for you as well. So, assuming my sales pitch on Aurora went over well, and you think, okay, let's see if I can get rid of all of those shards, save myself a lot of headache, maintenance, and overhead. How do I do it? Well, consolidating shards is not, or has not historically been, a simple process. We feel that the database migration service is a great way to go through that workflow and make it easier for you. So just a few minutes of introduction on DMS, as we call it, to give you an idea of what it is and how it works. So we know that customers have been looking for a way to migrate between engines and with minimal downtime. We also know they've been looking for ways to overcome technical challenges such as shard consolidation. And basically, people want to have flexibility to move their data from A to B, whatever A to B is. So this could be from one engine type to another, from on-premise to the cloud, or from a shard into a single instance. So it was with all these factors in mind that we developed the database migration service. We designed it to be simple, get started in less than 10 minutes, and we designed it to enable near zero downtime migration. Basically, we are hoping to make it a bit of a replication Swiss Army knife, if you will, to replicate data between on-premise systems, RDS, EC2, and across database engine types. It's important to highlight that although DMS is called the Database Migration Service, it can also be used for ongoing replication. So another very common area of use for it is to funnel information from all different database sources into a single data warehouse, for example, on an ongoing basis. So how is it that it works? how can DMS enable this near zero downtime migration? And in the case of this scenario that we're talking about, how can you enable a near zero downtime migration from all of your shards into a single Aurora instance? Basically, you start by launching a DMS instance in your AWS account. So this instance is basically replication software installed on an EC2 box. We manage it fully for you. You never actually log on directly to the machine, but you create tasks and configure it all through the AWS console or the CLI. Then you define the information on how to connect to both your source and your target databases. So these connections, although they're on the diagram as customer premise and AWS, the reality of it is it's sort of more like source and target. So your source would be your shard, and your target would be your Aurora instance. And just to be clear, AWS does not believe in lock-in, so you can very easily go from your Aurora instance back out to your on-premise system, no problem with that whatsoever. Once you've defined the connection information, which is basically just ODBC details, you specify what it is you want to move. DMS is a logical replication tool. That means we don't move things down at the block level. We're actually querying the database, extracting the information out, and inserting it into the target. In this way, you don't actually have to bring the entire database. You can just bring certain tables, schemas, or databases. You can maybe see where this is leading from a shard perspective. Then you let DMS create the tables, load the data, and keep them in sync. You can also pre-create your schema using the AWS schema conversion tool or an application of your choice. It really doesn't matter what. And then when you're happy that everything's in sync, or in the case of our scenario, you populated all the information from your shard to your Aurora target, you take a small outage and you repoint your application from the original source to the new Aurora target. And away you go. So how does it work? Well, as I mentioned, it's a logical replication software. It goes table by table. You can configure it so it does 4, 8 tables at a time, whatever you want. And it sets up the metadata required of the target. So if the table already exists, it doesn't do anything, it just loads it with data. If there is no table present, DMS will create it. Best practice, though, is to make sure you've pre-created your schema to make sure you get everything like your secondary indexes and your views and what have you all there. You can do multiple processes, you can pause, you can restart. It'll restart from where it left off if it's in a replication state. If you stopped it in the middle of what we call the initial bulk load, it's going to reload that table from the start. But generally speaking, it's going to resume from where it left off. It's a pretty low-touch replication package. So how do we do this? How do we make sure that you can keep all of your transactions flowing, your data can continually to be written to your original shard? Basically what it is we're reading the logging information from your database and keeping things in sync between source and target until you're ready to make the switch. In the case of MySQL, you basically just need to have row level bin logging turned on. We read those logs from the source database, funnel them through our replication instance, and apply them to the target after the bulk load is complete. It's a no agent install. We don't require you to put anything on your source system. We just reach out through the connection and pull the information back through the native API of the engine. So we talked about moving data. Obviously, the particular scenario we're going to talk about today is shard consolidation. Lots of people have done it in the past. Basically, you've got your multiple sources here, funneling all through the replication instance to the single target. Those sources, of course, can be MySQL shards, but kind of another interesting scenario that may be of use to some of you is that could be 3 different database engines. So if you had some data sitting in Oracle, some data sitting in MySQL, and more data yet again in SQL Server, nothing's stopping you at all using DMS to funnel that all into a single target, although generally speaking, that's probably going to be more commonly done for a data warehouse than an actual migration. As I mentioned, DMS is a logical solution. So what you can do is not only select particular tables, but you can also choose certain rows out of those tables. So you can do filtering on any field during the migration, not just on things like dates. You know, standard example would be, okay, only bring, say, the last 5 years of historical data, but you could actually filter by customer or, I don't know, by region, and only bring certain records over to your new target. Much like Aurora, we've had a lot of big customers use our service with a lot of success. Here's just a few again that you might recognize. There's a couple common between the two services, but it's been a very well received service that has been out now, I guess, since reInvent 2015 and continually improving. We release new versions and new connectors as well. So always keep an eye on our updates, because we very frequently add new database connectors which may be useful for you. So we've talked a bit about the solutions. How are we actually going to solve our original problem? So since you're running on MySQL, we're talking about MySQL shard consolidation into Aurora. The first step is actually to do what we call establishing a beachhead. So the beachhead is going to be your master shard, if you will, the one that contains the reference data. There's lots of different ways to move this information over, but probably the best way to do it is actually to set up a read replica using MySQL dump and import the data. Sorry. You can set up a read replica, you can do a MySQL dump and import the data, or of course you can use DMS. Really, I would actually suggest probably a good way to do it is to do the dump, because one of the things with DMS, just to be very aware of its limitations, is it is primarily a data mover. It doesn't move all of your schema objects. So if you want to use DMS, it's actually a two-step process. You first create your schema with your table structure, your views, stored procedures, triggers, what have you. You create all of that, and then you import the data. Actually, best practice is to make sure you disable your triggers until the import's done, but the long and short of it is you create your schema, you move your data, and you enable secondary objects like your triggers afterwards. A very simple way, if you can afford the outage, is to do the MySQL dump, move it across, establish your beachhead, and then worry about consolidating the rest of the shards from there. Once you've moved it across, then you make sure you update your mapping function. Again, this is that map that you see in the cloud at the top, to point to your Aurora instance instead of instance 1. So when you started, it looked like the diagram you see on the left. You had everything running in MySQL shards. You've done your backup, for argument's sake, into your new Aurora instance on the right. So now you've got Aurora there, and your your second, third, and fourth shards are still running on MySQL. So you got your before and your after. Once you've got that all set up, you've got to you have to go and continue moving the shards across. So before you do that, though, I would actually suggest you do a quick evaluation. I'm pretty confident Aurora is going to be running just fine for you, but you really should evaluate how well Aurora is handling your particular workload and make any required adjustments. Once you're satisfied with the configuration, you should migrate another shard. Obviously, in this case, it makes most sense to use shard number 2 into your Aurora instance. How do you do that? You can't do another backup. You can't take a backup from your shard 2 and put it back in that Aurora instance, because the information from shard 1 that contains that reference data is already there. This is where DMS comes in. DMS is just built for these situations. You can use DMS to copy the data from shard 2 into your new Aurora instance. Even better, you can do so while continuing to take transactions in shard 2. DMS will collect these transactions and apply them to your Aurora instance once the bulk data has been completely loaded. DMS will continue moving transactions from shard 2 to your Aurora instance to keep the two in sync until you're ready to use your Aurora instance instead of shard 2. When you're ready to flip between shard 2 and your Aurora instance, you simply stop taking transactions in shard 2, let DMS apply the final few transactions to your Aurora instance, update your map to direct traffic that was previously meant for shard 2 to your Aurora instance, and then you're done. So remember when I talked about how DMS worked, we read all of the transactions that are going into the log file, funnel them across, and apply them to the target. That's exactly what's happening here. We're first doing what we call bulk load of all of the data from shard 2, inserting it into the Aurora instance. At the same time, changes are still happening on shard 2, so we're monitoring those changes through the API. We get those changes in the form of transactions, apply them to the Aurora instance. Everything all looks good. You update your map in your application to no longer use shard 2, but instead the Aurora instance, and then you can basically turn off your second shard. At that point, things are going to look like this. So you can see we now have your Aurora instance with shard 1, shard 2, and reference data, and you've got your original shard 3 and 4 on your MySQL systems. From this point forward, you use DMS to migrate your final 2 shards into your Aurora instance. You want to ensure that you do configure these as CDC-enabled tasks to keep track of any changes, and these changes will flow into the Aurora instance as they affect the original shards, and in the end, your final system is going to look something like this. So great. You've now migrated your sharded system into a single Aurora instance and saved a bunch of money. But we've made a couple of assumptions here. We've assumed your shards are clean and your source database was MySQL. What if those assumptions aren't true? Well, we don't actually have time to get into every possible scenario today, but I can tell you that in the next few days, you're going to see a much more detailed blog published later, probably later this week. I would guess Thursday or Friday. The most obvious question, though, is, well, what if my source database isn't MySQL? Well, remember I mentioned that DMS doesn't really care what the source engine is and what the target engine is. DMS can funnel data from anywhere to anywhere of course, our supported engine list. And if you wanted to actually convert something like a legacy Oracle database to Aurora MySQL, take a look at the free AWS schema conversion tool. Again, good thing to highlight, it is free. Nothing stopping you from downloading it today and just running an analysis on your database. The schema conversion tool will automate the conversion of database schemas from one engine to another. It's not going to get a 100% conversion ratio, but it's going to get a lot of the way there and save you many weeks of work. But before you even start, I highly recommend you run what's called an assessment report and just take a bit of an analysis as to the effort that it'll take to convert your schema. Once you've converted it, as I mentioned, you just use DMS to move the data. All right, so I know a lot of these webinars, you probably see a lot of slides. I try to break things up a fair bit, so we're going to jump in and actually do a live demo of a MySQL shard consolidation. So now hopefully everybody can see a remote desktop session I have running. Up here we have the DMS console. Before we dive into DMS, let's just have a look at my databases. So I'm going to bring up my database query tool. dbeaver is just one thing I use, but frankly you can use any query tool you want. And we're going to look at some sample databases here. Now when this blog gets published later in this week, you'll see that it also includes references to these same sample databases that I'm using in the demo today. So you can actually give this a shot yourself, work through the blog end to end, and really get comfortable with the process before you dive in and do it on your production database. For the sake of simplicity and speed, I have skipped a couple steps in the process, and what I'll point out is that I have actually one shard here, a MySQL shard, and a second shard here. Now these are completely separate instances. They happen to be running on RDS, but I've got my 2 shards. But I've actually done the first step of the process already. And by that first step, I mean I've already taken a MySQL dump and restored it to an Aurora instance. So remember, shard 1, in the example we worked through, contained all of the reference data for the application. So I've already done that just to save some time. If we go and we look at the schema for this database, you can see that it has a number of tables in here. This is a sample database that actually Ed, who's one of the moderators today, built for us. And it's basically a hypothetical sports ticketing system. So we've got a lot of tables here. But if we go down and we look at one of our shards, you can see that we have only a few tables. And the same goes if we look at the second shard, we have the same collection of tables in this shard as well. So we have these 3 tables that are split out by shard. The person table is actually just reference data, not really applicable to this demo. It's there because there's some scripts that this database can run to generate transactions, and it's just needed as a reference to allow those scripts to execute successfully. But it's these sporting event ticket and ticket purchase history tables that we've sharded between the 2 instances. So we'll start off and take a look actually at the sporting event ticket table in the Aurora instance. So you can see up here at the top, I've connected to my Aurora consolidated database. If I run this query, Just go here and execute it. Down at the bottom, you can see I have an empty table. If I then go and switch to my shard, run that same query, you can see I've got a bunch of data in there. And likewise, if I switch to my second shard, run that same query again, a different set of data. So you can see this is ID 1234, switch back to shard 1, run the query, and you can see I've got IDs starting at 65,000. Now the reality of it is it's actually broken up in a much simpler way than just some arbitrary number. If I go and execute it, or execute this query, you can see it's broken down by sporting event ID. And what this means is this shard, which is shard 1, includes all of the even sporting event IDs. And if I run the same query on shard 2, it has all of the, as it runs, odd sporting event IDs. So that's how my shard is broken up, simply by sporting event IDs, bit of a mod function, just figuring out how to split things. Obviously, our drive here is to consolidate all this information. We want all of this into my Aurora consolidated database. So at this point, we'll go and we'll connect to DMS, and I'll show you how it is we do that. So for those of you that haven't seen DMS before, it's just available right off the Amazon console, just one of the many services you can see here. It's over in the migration section down here. So DMS is available to everybody to use. Obviously, I've already got it selected, so I will just go back here. We can start off with the dashboard. We tend to announce some of the new things that happen here. And if you want to do just a simple test migration, you've never used DMS before, we have a bit of a step-by-step wizard you can use to go through. We're not going to use the wizard today. Just talk about some of the basic overview. If you think back to that slide I showed about how DMS works, DMS is in essence just a few components together. You've got your replication instance, which does the processing. This does the actual extracting and inserting of data. And then you've got your endpoints. This defines the connections, if you will, the connections from your source to DMS and from DMS to your target. You can have as many endpoints as you want. You can also have multiple replication servers. So if you have lots of big tasks running, you can split that up between different replication servers and balance the load. Always just like to highlight though, when you're done with your migration, done with your replication, a DMS instance is just like any other server in AWS. If you're done with it, you got to make sure you turn it off at the end. All of the pricing for DMS is on our website. The long and short of it is it's an extraordinarily cheap service. Anybody that's looked at any commercial replication software in the past, to say we're massively cheaper would be an understatement. We can generally say you can migrate a terabyte for the order of a few dollars. We have two classes of replication servers available, T2s and C4s. T2s are great for dev and test, C4s are good for production. It's kind of interesting, the C4s process data that much faster than the T2s, such that even though they cost more money per hour, they process it that much faster that they end up being cheaper in the long run for migration. T2s are a good thing to think about though if you have an ongoing replication into say a data warehouse you want to have going for years, because if you don't need a huge amount of processing power because you're just taking transactions as they come, there's nothing wrong with them whatsoever. So just going through the console, replication instances, I have about 10 of them running. You probably don't need anywhere near this many. We're going to use this one called Shard Test today. So that's actually running a fairly small instance class, but we're just using a demo database, so not a big amount of processing needed. You can again, as I said, have many different endpoints. I have quite a range of endpoints here. We're actually only going to use 3 endpoints today. My 2 shards as a source right here, so shard 1 and shard 2, and then my Aurora target I'll also be using to write data into. That's this endpoint at the top. So a migration is actually a collection of tasks. I've pre-created the tasks, again, to just save a bit of time and show you how it works. If we take a look at this task, we will see what it is that we're trying to move. So I've hit modify, and you can see the rules that I've set up. So remembering that I mentioned that DMS is a logical replication tool, what this means is we can extract only certain amounts of data. So we're looking to extract information from my shard, from the DMS sample schema, and include all tables. So that's a wildcard. It's basically saying grab every table that's in the schema, except the person table. So remember I mentioned that person table is just for reference data. So we want to say grab everything in the shard except this person table. All sorts of different rules you can create. Again, as I mentioned, certain rows, certain records, certain schemas, certain tables, and you can do some transformation rules as well. So if you wanted to change the table name as you are migrating it across, there's no problem at all with doing that. The other common thing that we get quite a lot is some databases like to have everything in uppercase, some databases like to have everything in lowercase. So when you're doing a migration, sometimes you need to add a transformation rule to change every item in your schema from upper to lowercase. Just some of the things you can do with DMS. And if you want to get really fancy, you can even switch to the JSON tab and write your own mapping rules yourself. DMS, like everything else with Amazon, is fully accessible through this console and also the CLI and the SDKs, so you can do the whole thing programmatically if you have hundreds and hundreds of shards to move and consolidate. Just want to point out there's different migration types or basically styles of tasks you can run. In this case here, you can see we've got migrate existing data and replicate ongoing changes. So remember that there's what I've been referring to, the bulk load component. This is where we're going to extract all of the data from the system. And then there's the replicate changes, which are just grab changes that are coming in. So you can do one, all, or both of them. In this case, we want to do both because we want to move the data from our shard and allow that shard to keep taking transactions until we're happy that the migration has been successful, and we update our application layer, or again, remember that map cloud, to point to the Aurora instance. So that's why I have migrate existing data and replicate ongoing changes. I'm just going to cancel out because I don't really need to change that at all, and then I will start the task. So I just select the task and hit start. Hold on one second. Tasks, and I'll start it. This is always fun when this happens. Just give me one sec. I think I may have left it a bit long before I started the demo. Select the task, start it up. Here we go. So I need to go and, because I've run this before in the past, I'm actually going to restart the task. Because remember, as I mentioned, DMS can resume from where it left off if there's any interruption. I just want to make sure I start right over at the start because I went before this webinar started and purged out all of the records in the Aurora target database. So I'm going to restart and do the, as it says, initial full load operation. So I'll start that task. You can see it now says starting. I could also start that second one there. I'm not going to do it just yet, just so I can show you guys the results. I'll just give it a second or two to kick off. Basically, the console at the moment is communicating to the EC2 instance with the replication software and telling it to kick off the task. So it's actually communicating right back through the same REST service, if you will, that you would use if you were using the CLI to create and start a task programmatically. Once that task gets going, I can switch back to my database query tool. Go here, so I am going to look at my Aurora instance and do a quick query on my sporting event table. And you can see the records have already started flowing in. I've got 200 rows, as you can see down in the bottom, even though I said limit 1,000. That's because in the short amount of time that I've been talking, DMS has already loaded 200 rows into the system. Now remember, I mentioned that the shards were broken down whether the sporting event was even or odd. So if I do a quick query again to look at the different IDs, you can see that I've now only got all of the even sporting events in my Aurora consolidated instance. If I switch back to DMS now and start that second DMS task, so this is the one that pulls information from shard 2, I'll do the same restart that I did on the other one. Give it a few seconds. And actually, I should also mention you can monitor all of these things through the dashboard. So you can see that shard 1 consolidation has been running now for 2 minutes. The second one hasn't started up just yet. So So back to the tasks, give it another second. I'm going to assume that it's probably started running by about now. And rerun this same query. Actually, I'll run both of them. Go in here, run the query. You can see I now have, well, this is all sporting event 1 because there's a lot of records in there. But if I run this query that groups them all by the sporting event ID, we should now see that we have both evens and odds. And sure enough, there we go. We've got sporting event 1, 2, 3, and 4. So really, it is that simple. That's how you can consolidate multiple shards into one single instance using a combination of a MySQL dump to do your initial import of all of your tables, including your reference data, and then you use DMS to move all of the shards in as well. As I mentioned, you can use DMS for that initial load too. Just sort of depends on what you're comfortable with and if you can take any outages there. So that is how you do MySQL shard consolidation in Aurora. I've finished pretty much on time. I think now is a good time to switch back to the forum and I can answer some of the questions that you guys have been asking during my presentation.